So this is your summer 23 paper. So the first question is do the electron configuration and arrangement of atoms or ion. So if you look here, the first question says what's the electron configuration of V? So if we look here, it's 2, 4, so it means 6 electrons. So what atom could it be? So we have to look for the symbol, carbon. Then you have to draw the electronic configuration. If they ever ask you, let's do your shells. So it's got 2 shells, 2 in the first shell, and then you have 6 on the outer shell. Next question is to do with ions. So if you look here, this is a fluoride ion, not fluorine. So make sure you don't say fluorine because you get marked wrong there. The next one, single positive charge sodium is Na+. Double negative charge, so it's 2/8, which means it's got 10 electrons. So it has to be, look at neon, if we go across, double negative, if we go back the ways, it meant to have 8 electrons, so it's O2-, so it's an oxide again, not oxygen. Y represented by the electron configuration of an atom. How many protons does it have? So Y has got 13 electrons. So what other else? If we look at the periodic table, same number of protons as electrons, so 13. Period 4 means it has to have 4 shells. Look up here, it is Z. Then we go on to calculating our relative atomic mass. So we know that these are 46 times 8.3, so you just take your atomic mass number multiplied by your abundance, and you add all the values up and you divide it by the total abundance. Now be careful if your total abundance doesn't add up to 100%. If it adds up to something else, just make sure you work that out. Ends up with your answer of 47.918, and then you round up to 1 decimal point, so it's 47.9. Next one we go on to complete the table. So chlorine, if you look at chlorine, it's a yellow-green gas. Which one's red-brown? It is bromine. And bromine is a liquid. It and mercury are 2 liquids at room temperature. Other gas we have here is fluorine, which is a yellow gas. And the other group 7 as well is iodine, which is a grey-black solid. Now be careful, it doesn't say iodide, it's just talking about the atom here. So group 7 is belong to the halogens, group 0 is noble gases. Group 1 is alkali metals, group 2 is alkali earth metals. So the next question we go on to is do a displacement reaction. So as I already told you there, bromine plus lithium iodide. So we should already make that first mark there. Then it forms into lithium bromide plus iodine because bromine's more reactive than iodine, so it displaces it. Double check your valency, so swap and drop your charges. So 1 and 1, so that's completely fine. LII is correct and LIBR is also correct. During the reaction, bromine molecules react to form bromide ions. So bromine molecules, so write down bromine first, so Br, to form bromide ions, so it's Br minus. Again, we know that we have gained an electron here because you gain negative charge. Bromine is diatomic, so it should be 2. So you need 2 electrons and 2 ions. What colour is it in the solution? It's colourless. Remember, any solution that you think about in this tense of metal and non-metal, they're mostly colourless. If it's a solid, it's a white solid. What it'll form is a yellow-brown solution because the iodine causes it to be yellow-brown. If there was bromine in the solution, it would be an orange, and if it was chlorine, it would be colourless. But remember, you don't use fluorine in the lab for this reaction because fluorine is toxic. Okay, so we won't use fluorine in the laboratory because it's toxic. That could be a question also. So these are many different terms to describe a pure substance, a mixture, or a formulation, or an alloy. So name a compound here. So if we go through them all, we look for a compound. So a compound is made up of 2 or more elements chemically bonded together, and the only option here is sodium hydrogen carbonate. Name one element in the table with a solid non-metal. So looking through here, element has to be a single element, so it's definitely not sodium hydrogen carbonate. It can't be any of the ones I've X'd there because they're all metals. All of air is all gases, so they're not a solid either. So they're out, and so zinc and copper, so the option here is silicon. For this one, using the information, complete the table, place and tick on all the terms that apply for each. So for brass, it was mixture, formulation and alloy. Air is just a mixture. Baking soda is pure substance, and steel is like the alloy. Pure water is 100 degrees, and there's no change in the water there. Then we look for the test for water. So the test for water is anhydrous copper 2 sulfate. Please ensure you include the word 2. It goes from a white solid to a blue solution. I didn't ask you to change the state there, but it is a white solid to a blue solution. So the next one you know is test for hydrogen. It's a glowing splint, and what happens, it'll burn with a squeaky pop. I should say lighted splint burns squeaky pop. Then we have oxygen, so it relights a glowing splint. So remember that hydrogen one should be saying lighted splint burns squeaky pop. carbon dioxide, lime water goes from colourless to a milky solution. And test for chlorine is universal indicator paper, and it will go red, and then it will bleach white. Again, I repeat there, the test for hydrogen is lighted splint burns with squeaky pop, not glowing splint. Next thing we'll go on to is name the type of bond and present in magnesium. Is a metallic. The stuff beforehand confuses you and make you think it's ionic. For this question here, be careful to use dots and cross. So magnesium we know is 12 electrons, so it's 282. Chlorine is 287, but use dots to represent one or the other. Explain in terms the changes of electronic configuration, how magnesium atoms and chlorine atoms react to form ionic compounds. So we needed to have 1 magnesium and 2 chlorine. So the magnesium atom loses 2 electrons, giving 1 to each of the chlorine. And again, as I repeat that, you have 1 magnesium and you have 2 chlorines. Explaining magnesium ion is more stable. The ion has a full outer shell and is stable. Okay, so that's what you mentioned there. The ion has a full outer shell and is stable. And then to draw your covalent bond of oxygen, O2, because you know it's got 2 oxygen molecules, 2 shared pairs because it's group 6. It needs 2 electrons, so that's how many shared pairs it have. And then fill out your outer shell. Then we go on to question 5, is making your formula. So we know it's going to be called magnesium nitrate. So we know magnesium Mg2 plus, nitrate's NO3, 2 minus. So double check the back of your periodic table, that's where you'd find them ions, 2 circular charges, so 2 and 1. The 3 doesn't get affected, remember. So you have 1 magnesium and 2 nitrates, but you put brackets because you need to include both nitrogen and oxygen. So your formula is Mg bracket NO3 2. This one's called potassium dichromate. You'd find Cr2O7 at the back of your periodic table. Next question. Solid calcium carbonate reacts with water and carbon dioxide to form a solution of calcium hydrogen carbonate. Calcium carbonate, swap and drop your valence down should be correct, plus your water plus CO2. State symbols, I told you there the calcium carbonate was a solid, so you should put S beside it. We know that water is liquid, it's the only liquid there is, and carbon dioxide is a gas. Element X, which is unknown element. X reacts with oxygen according to the equation below. Suggest one element that could be element X. So you work your way back up from swapping and dropping. So you would know that if you swap back up, oxygen was 2 minus, so it has to be 3 plus for element X. So that could be Fe3 plus, or it could be aluminium. Okay, so suggest the element would be aluminium. Write the formula of the compound form when X reacts with fluorine. It would be Al3 plus, F minus. When you swap and drop, you'd end up with AlF3. Then we go on to our quantitative chemistry questions. So to work out your number, your relative formula mass, you have 3 sodium, 1 phosphorus and 4 oxygen. So 23 times 3 plus 31 plus 16 times 4 gives you a total of 164. Lead nitrate, 1 lead, 2 nitrogen and 6 oxygen. Because remember the brackets, you multiply everything inside it. So 207 plus 14 times 2 plus 16 times 6, which gives you a total of 331. Calculate the percentage by carbon by mass in magnesium butanoate. Gives you the relative formula mass. So basically all it's saying to you, how much carbon is there in that molecule. So if you work out how much carbon there is, you divide it by the total amount. So if we work this out, 2 times 3 would give me 6, and then 2 times 1 gives me 7 from the carbon. So 6 plus 2 gives me 8. So you have 8 carbon, and you work out using your relative formula masses. And this will then give you 96 over 198, times it by 100 to get your percentage, gives you 48.5%. Equation below, reaction of dinitrogen tetroxide. Calculate the theoretical yield. So this is just basically a way of saying calculate the mass of nitric acid. So that's your 4HNO3. What you will do is you'll first of all work out what dinitrogen tetroxide is. You never heard of that before, but it tells you in the question, so all the information is there, and the ratio of it to your nitric acid. So what we have is we know that there's 45 moles. The ratio is 3. So 45 divided by 3 gives me 15. You keep that number the same along the bottom. The ratio up is 4. So go up the way as you multiply, gives me 60. And then to work out your mass, what you will do is mass equals moles times RFM. They've already told you the RFM is 63 there. So it's going to be 60 times 63, which gives you a total of 3780. Then we go on to calculate our actual yield. So it's the actual yield of nitric acid. So actual yield over theoretical yield times 100. This is your theory, or this is your calculation. So what our actual yield was, we don't really know. That's what we're trying to work out. So it's like sort of working back the way as using your algebra. So we know that we don't know actual yield yet, but we know that our theoretical yield that we should have got was 3,780. Would have got error carried forward. Mark say you got that one wrong. And we know that our actual yield is 85%. So when we work this out, it would be 85 divided by 100, which gives 0.85. Then we just multiply that by 3,780 to work out our x, which is a value of 3213. Table below shows formula of several ions. Here we go. So write the formula. So you only can use the tables from above. Write the formula of ion which we use to make a blue solution. So blue solution we know is copper sulfate. Okay. So the formula for ion which we use Cu2 plus because that we have that there. Write the formula of two ions that are present in sulfuric acid. So H plus and SO4 2 minus. Next thing we'll look at is a green solid compound that we form from two ions, which would be copper carbonate, CuCO3. Remember, copper oxide is black and copper sulfate is a blue solid. Then we look at the four ionic equations below here. So what ion's missing? So it's OH minus for the first one to form water. So H plus would give hydrogen. To give water you need a hydroxide ion again. And then to form carbon dioxide you always need a carbonate ion. Next one's the name type of reaction in A. So A was neutralization reaction. If you're ever asked, then H plus plus OH minus gives H2O. And the state symbols are aqueous, aqueous and liquid. Then we go on to potassium reacts with iodine to form potassium iodide. See the colour and physical state of iodine and potassium iodide at room temperature. So iodine at room temperature is a grey-black solid. Make sure you use sentences with capital letters and full stops. Don't just say grey-black solid, use a sentence. Next one, the colour and physical state of potassium iodide. Potassium iodide is a white solid at room temperature. Then we have name and description of the structure and bond of iodine at room temperature. So iodine is a molecular covalent structure with covalent bonds with weak van der Waals forces between the molecules. If you're asked again about temperature or about boiling points, they have low boiling points, remember, because there's weak van der Waals force between the molecules, but the covalent bond itself between two molecules is strong. Like iodine, there's a strong covalent bond between that two iodines, but different. So potassium iodide is an ionic bond with an ionic lattice, and that is it finished.